video is going to go through the first part of the notes for 2-3, factored form of a quadratic function. So we've already talked about two different types of forms of quadratics up until this point. We have vertex form, which I just underlined in red. We have standard form, which is underlined in green. And then finally, we have factored form, which is underlined in blue. Factored form is useful because it actually tells you what the x-intercepts are of a quadratic function. Your x-intercepts are going to be your p and your q values. Now keep in mind the equation does have subtraction in it. So just like when we pulled out the h value, we took the opposite, we would pull out the opposite whenever we do our p's and q's. So we're going to start off with some factoring, and I do have multiple examples of this. However, this is something that you may want to supplement with other videos and other lessons, possibly from Khan Academy or other sources. There are a couple of different ways to factor. I typically show the trial and error method just because once you get it, it is something that goes a lot faster than having to go through the longer grouping process, which is what some sources use for Part B. So for Part A, I have my three terms. I need a factor. Factor just means I'm going to write this as two sets of parentheses, each with two terms. This is basically FOIL in reverse. So you are undoing what was done with FOIL to get rid of the parentheses to put your terms back into parentheses. When your first term is an x squared, the first term in parentheses has to be x and x. Because just like when we're thinking with FOIL, x times x is equal to x squared. Now again, this is an easier example because again, your a value is equal to 1. And when that happens, you're looking for factors of the last term that would add together to equal the middle term. If you remember through FOIL, when we multiply our outer and our inner terms together, they become whatever's in the middle of my function. So I'm looking at factors of 12. We want to think what factors of 12 would add to make a positive 7. Well, that would be a positive 3 and a positive 4. And again, it doesn't matter which order you put them with as long as the appropriate sign is with the appropriate number. So if I check this, like if I check multiplying along the loops that I have here, x times 4 is 4x, 3 times x is 3x, that gives me my 7x, which is the middle term in the problem. So that means this is the correct factorization. Now B is a little bit more difficult because in this case, A is not equal to 1. So you're not just looking at the factors of the last term, which you should see there are no factors of -3 that would make a -5. But when you throw the 2 into the mix with multiplication, then it is going to be possible. So I am going to set out my 2x and my x. And now I need to consider factors of -3. So with -3, those factors are going to be -3 and +1 or +3 and -1. And I need to use the appropriate ones to make sure my OI terms, the outer and the inner, add to make a -5. So if I think about this, whatever number is here is going to be multiplied by the 2. Whatever number is here is going to be multiplied by the x. Well, I know if I multiply a 3 by a 2, I get to a 6, and that's kind of close to a 5. And then when I tack on the 1, and I am going to be subtracting because of the way the signs work out, that's going to work in my favor. I just need to make sure I get the negative here. So I want the 3 to be a negative and the 1 to be a positive. And if I double check that, 2x times -3 is -6x, 1 times x is 1x. That gives me my -5x, and that checks out. Now, there are many additional questions that we could do with this, and I did do some additional practice with with my students that were in class. However, in moving through the notes for the lesson, I'm going to skip over those slides. I will be linking to some other videos to give you some additional practice questions if factoring is still not quite making sense. So now we pick up with example 2, and example 2 is the main reason why we want to factor. It goes back to that factored form that I showed you on the first slide. So we have this graph here that shows the equation y equals x squared plus 2x minus 8, and we want to see how the zeros of the function are going to relate to the factors of this expression. Well, first of all, I want to talk about the word zeros. You will see zeros interchanged with a couple of different words. Zeros mean the same thing as x-intercept, means the same thing as root, and means the same thing as solution. So all 4 of those words are used interchangeably in different situations. In this one, we're calling them zeros, but they're really x-intercepts. So let's go to our factoring and see what happens here. X squared plus 2x minus 8, again, the coefficient of the x squared is a 1. So that means I'm going to have an x and an x. So now I'm looking at factors of negative 8 that would add to make a 2. Well, things that multiply to make a negative number, I'm going to have one of each sign, and they have to be 2 apart. So I'm probably going to be using 4 and 2. Since I want them to add to a positive 2, I want the 4 to be positive and the 2 to be negative. If you look at the factors of the positive 4 and the negative 2, and then you look at the zeros of negative 4 and positive 2, you can see they're opposite. So the factors and the x-intercepts are actually opposite. And the reason for that has to do with the fact that these are zeros, and we're going to be using something called the zero product property. Both of these x-intercepts have y values of 0. Which means the y value, if I go back up to my original problem, I would be replacing that with 0. The only way to multiply 2 things and get 0 is if at least one of those things was 0 to begin with. Which means for the x plus 4 set of parentheses to be 0, x would have to be negative 4. For the x minus 2 set of parentheses to be 0, x would have to be 2. And notice, once I actually solve those factors using that zero product property, that's how I get the negative 4 and the positive 2 that are my x-intercepts. That would be the solutions or the roots or the zeros to the problem. And that's the whole reason why factoring is important to quadratics. It allows us to find the x-intercepts if they are real. So the zero product property you see up there at the top, and again, that's what we just used. If the product of some real number or a set of real numbers is 0, then at least one of the factors has to be 0. So now we're actually going to go through and solve. This is doing the same thing that we were doing with factoring, but instead of stopping at the parentheses, you're going to keep going and actually find what x equals. You'll know that you need to solve rather than just factor if you see an equal sign in the question. If there's an equal sign, then that means that just the parentheses aren't going to be enough. You do need to get everything on one side. So for part A, we do have to subtract the 42. This is, again, one of those easy ones because I don't have to consider the factors of the first term because that's just going to be x and x. So now I'm looking at factors of negative 42 that add to make 1. So factors of 42 that are 1 apart are going to be 7 and 6. I'm making a positive 1, so I have a plus 7 and a minus 6. To finish this out, you set each factor equal to 0, and then you solve. So we get x is negative 7 as one solution, and x is 6 as another solution. So if you were to graph the quadratic, x squared plus x minus 42, it would have x-intercepts at negative 7 and positive 6. Part B, again, we are going to have to move terms. Just a helpful hint, even though it's longer to move everything to the left, you do always want to keep your quadratic term positive. It'll make your life a lot easier. Because factoring whenever your quadratic term is negative can be really, really ugly. So I suggest moving everything to keep wherever your square term is to keep that positive. So I'm going to add the 9x and subtract the 5. So my first term has that, it's a 2x squared, so I'm going to have a 2x and an x. Again, I'm going to be thinking about whatever term is in this last spot is going to be multiplied by the 2. Factors of 5, I'm either using -1 and +5 or +1 and -5. I do want to try to get to 9, so I probably want to multiply the 5 by the 2 because that gets me to 10, and then I have a 1 left over I can take away. The 9 is positive, so I'm going to be adding 5, subtract 1. And you can see that would give me 10x minus 1x, so that does check out to give me what I'm looking for there. So now this is a solution, this is one that we have to solve, so I'm going to take my sets of parentheses and set them equal to 0. The x plus 5 one is easy to solve. You would subtract 5 from both sides, and you get x is equal to -5. Now with this other one, anytime, unless there is a greatest common factor, which hopefully we'll talk about a little bit later on, anytime your x has a coefficient with it, typically you are going to get a fraction in your answer. So I would add the 1, we get 2x is equal to 1, then divide by 2. So x is equal to 1/2. So your solutions for part B are 1/2 and -5. Again, if you were to graph the quadratic, 2x squared plus 9x minus 5, it would have x-intercepts of 1/2 and -5. This is where factoring really has the benefit over graphing because there's no guesswork involved with what the x-intercepts are. If you do get a fraction as an x-intercept and you were just looking at a graph, you may not be able to tell exactly where that x-intercept is, so it's nice to have factoring to confirm that. So that's going to wrap up this particular video on factoring. Again, I am going to try to get some more resources out to you guys to practice this information. So go back through, watch anything you weren't quite sure of, and contact me if you have any questions.